tracES++, applying incremental computation to temporal information diffusion analysis for online object traceability. A paper by Gaza and J. Byun from Sejong University, South Korea. Object traceability in the supply chain is a complex process as several objects are continuously transported to different locations, transformed into new objects, loaded into containers, unloaded from the containers, and sold by the stores. To ensure product quality, safety, and visibility, several stakeholders such as the supplier, manufacturer, and seller manage the supply chain data. To enable real-time object traceability, tracES++ incorporates three key technologies. EPCIS, which stands for Electronic Product Code Information Standard, is a global standard to capture and share supply chain data across different institutions. Previous research shows that object traceability is closely related to temporal reachability. Temporal graph converts the EPCIS data into temporal graph elements to enable temporal graph analysis. This solves the scalability issue brought about by the successive transformations and aggregations of objects. Incremental computation enables real-time monitoring to reduce the number of queries and prevent the recomputation of the temporal reachability for every query. EPCIS enables object traceability by defining the data structure of objects and events, and the service interfaces to capture and query them. It has two interfaces to interact with external applications. The EPCIS capture interface interacts with the data capture application or DCA. The DCA formats the supply chain data as an EPCIS document and sends it to the EPCIS system. The EPCIS query interface interacts with the EPCIS accessing application or EAA. The EAA formats a query and sends it to the EPCIS system to receive an EPCIS document. For the implementation, we use Olead EPCIS, which is an open-source EPCIS system complying with the latest EPCIS version 2.0. For the temporal graph, we use chronograph, which is a temporal graph processing engine that is based on blueprints, a de facto standard for property graphs, and its traversal language, Gremlin. Chronograph extends the generic graph application programming interface of blueprints to create, retrieve, update, and delete temporal graph elements. The complexity of object traceability lies in the successive transformation and aggregation events in the supply chain. Thus, we highlight here the conversion of the transformation and aggregation events into temporal graph elements. Specifically, for a transformation event, a source and a destination are converted into vertices, and the relationship between them is set as an edge with a label, is transformed to valid at given time. Similarly, an aggregation event, a child and a parent are converted into vertices, and the relationship between them is set as an edge with a label, is contained in valid at a given time. As an example, this EPCIS document containing an aggregation event is converted to the following temporal graph elements. Lastly, by incorporating incremental computation, we prevent the traceability results from being processed again and again when new supply chain data comes. Incremental computation allows us to incorporate the new supply chain data into the existing traceability results. For the implementation, we use Kairos, which is an incremental temporal processing engine that can handle temporal information diffusion analysis on an infinitely evolving temporal graph. tracES++ is an enhanced EPCIS system that incorporates a temporal graph engine and an incremental program into an EPCIS system. Moreover, it extends the EPCIS query interface to allow monitoring applications to subscribe a traceability query to the EPCIS system. As a demonstration, we show a monitoring application subscribing a query to tracES++. Since we have not captured any data yet, we can see that the object has no events associated with it. Then, the DCA continuously captures EPCIS documents containing EPCIS events. We can see that once an EPCIS document affects the traceability results, the monitoring application will receive an update containing the new traceability results. By incorporating incremental computation to temporal information diffusion analysis, we enabled online object traceability in our enhanced EPCIS system called tracES++.